This is Unsiloed, brought to you by Alumni FM, connecting people through stories.
Welcome to Unsiloed. This is Greg LeBlanc, and I'm here today with Gary Smith, who is a professor of economics at Pomona College. He's also the author of, quite a few books, most recently a book called Distrust, Big Data, Data Torturing, and the Assault on Science, which I have here. Also a whole bunch of other books, including Phantom Pattern Problem, 9 Pitfalls of Data Science, The AI Delusion, What the Luck, bunch of other ones on finance, and of course, the classic standard deviation, flawed assumptions, tortured data, and other ways to lie with statistics. Welcome, Gary.
Oh, thank you for having me, Greg.
Well, I like the fact that you cross so many disciplines. You teach in finance, you teach in statistics, you teach a lot of the different areas that I teach in, and your work is really, particularly this most recent book, is really about, I think of it as two separate things. One is sort of the popular misunderstanding of science and inference, right? How people in general do kind of a poor job of understanding science, right? But then there's this second sort of strand, which is how, the scientists aren't really doing science, all that much service because of the ways that they kind of abuse science, right? And in part, right, it's the latter that's maybe driving some of the former, right? I mean, if scientists can't get it right, then how can we expect ordinary people to get it right? So I think of part of what you're doing is you're kind of serving as a watchdog or police officer that's patrolling the world of science and calling out kind of shoddy workmanship. And when I teach, I teach data and decisions. I've been doing that for a couple decades now, and I spend most of my time, talking about how not to do it, right? How I mean, and so I'm so excited that in other domains like psychology, and you spend a lot of time talking about social psychology because that's kind of the whipping boy for the last couple years of p-hacking and HARKing and all of these methods. But finance has been doing this for even longer, and I think that finance has been, when you try it out in finance, and you're trying to actually make money with it, you very quickly realize the flaws. But if you're just publishing academic articles, right, the harm is kind of invisible, and so that's why It's kind of taken longer, I think, for people to go after academicians. So, do you think of yourself as sort of a necessary corrective? Do you think that we should bake in this kind of correction into every single department, discipline? Should we have an equal number of, or even a larger number of people who are out there trying to, patrol the research than, having people do research themselves even?
Yeah, I didn't start out as a data sleuth or that kind of person, but I sort of stumbled into it. And it all goes back, of course, to Fletcher, who said anything worth publishing should have a p-value less than 0.05. And everything else should be ignored entirely. And of course, nobody wants to be ignored entirely. And scientists are pretty smart. So they start figuring out ways to get their p-values below 0.05. And that led to all these nefarious procedures. And a lot of them, people didn't realize that they were doing bad things. And so, like in social psychology you mentioned, I was at a conference called SciFu up at the Googleplex. And there was a prominent social psychologist from University of Chicago. And he said, my default assumption is anything published in my field is wrong. and the problem was, people say, nowadays they say, at the time we did it, we thought that's the way stats was done. And if it was wrong, it was kind of wrong like jaywalking. Now we know it's wrong like robbing a bank. And so taking a set of data, trying to get some conclusion, you don't quite get statistical significance. And so you think, well, what harm could it be if I throw out a few observations? Or maybe I should look more closely, divide it into males and females, divide it in different races, different ages, different countries, different, whatever. Keep going until I find something and then pretend that's what I was looking for all along. And the irony here is, there's a couple ironies, but one is, we statisticians say correlation is not causation. And people are so sick of hearing it. In that that's what these people are doing. They're just looking for correlations and pretending they're meaningful, even though we all know if you look for correlations, you will eventually find something. And all it proves is you looked. And the other irony is Fisher set out this idea of statistical significance so we could distinguish between coincidences and real effects. And now it's been abused, and what we're getting is a lot of coincidences. And so trying to be scientifically rigorous has actually undermined the credibility of science in this field.
Well, I mean, I think what Fisher was trying to do, I mean, it's ironic that rule is abused because, you know, the whole point of having a p-value was to kind of serve as a corrective to confirmation bias, right? I mean, the idea was that if you started with a null hypothesis that was contrary to what you were trying to demonstrate, then, you know, the burden of proof was on the thing that you're trying to demonstrate. And so we're trying to keep the number of false positives to a relatively, you know, low number. And so in theory, I mean, the whole purpose was to overcome confirmation bias. But you also cite Goodhart's law, which is that once you kind of set in place some kind of rule, then everybody devotes effort to kind of outsmarting the rule, so to speak.
Exactly. And Fisher, you can't argue with it. P-values are great. The problem is when you set that as a goal, like Goodhart's law, then it ceases to be a useful measure. And so we have also the great quotation from Ronald Coase, of course, the Nobel laureate in economics, that if you torture the data long enough, they will confess. And so that's what people have set out to do, to get published, to get a job, to get tenure, to get funding, to get famous. I have to have publishable results. And to get publishable results, I need to have p-values below 0.05. So I'll do whatever's necessary. I'll torture the data until I get my 0.05. And then the problem is you publish these studies and somebody else tries to replicate it and they don't replicate. And so it undermines the credibility of science. And it has the opposite effect of what Fisher intended.
Well, what's funny is that there are a bunch of cases that you describe in the latest book of researchers who were quite transparent about their tricks, right? And they were proud of them, right? And they bragged about them, and they wrote about them. So like Brian Wansink, right, who wrote all those wonderful. I mean, I call them wonderful because they're great stories about food. I used to cite them all the time in my classes because they made so much sense. They're like, oh yeah, this is totally so cool. It makes sense, right?
Yeah.
But he actually bragged about how he coached one of his graduate students into torturing data, and then when people gave him a hard time, he couldn't understand what he did wrong.
Yeah, exactly. And so one of the fundamental problems here, I think, that needs correction, and everyone's working on it, is a recognition that p-hacking and HARKing are, in fact, not just jaywalking. They're like robbing a bank. And people have been doing it. You're just thinking that's just the way science is done. And Wansink is a great example. I mean, as you say, he was world famous, books translated into hundreds of languages. And he had this easy message, which is the best diet is one you don't know you're on. And so you serve your food on brown plates and you have a kitchen with pastel colors, and next thing you know, you're losing weight. And it just sounded so great, so easy. But then, like you say, he just bragged about, it was a blog post he had, The Girl Who Never Said No. And what it was they gathered all this data they went to all-you-can-eat Italian restaurant, and they started recording all these things. What kind of people were at the table, what their ages were, what their sexes were, what kind of food they ordered, did they order drinks, how many slices of pizza did they eat, and they had all these data, and they analyzed it. They couldn't find anything, and he told the girl, don't give up. You seldom find what you're looking for on the first try. We need to try harder and separate the data, just like I was saying before, separate it by sexes, separate it by kinds of food, separate it by how many people at the table. We got to squeeze some blood from this rock. And he ended up with things like, when a man eats pizza with a woman, he tends to eat nearly twice as much pizza. Who knows if it's true or not, but it was just torturing the data until he found something with a p-value below 0.05. And he bragged about it because he didn't, and even after he lost his job, he didn't seem to realize that he'd actually done something wrong. And it's just...
And well, it wouldn't have been wrong 20 years ago, right? I mean,
that's right.
If he posted that 20 years ago, I think people would have been like, bravo, right?
Yeah, yeah. And Andrew Gelman, the statistician at Columbia, has written about how in these fields like social psychology, that's just the way it was done. The graduate students were taught this is how you do social psychology research. You get some data and you look for correlations and then you publish your results. And if you have to tweak the data a little bit, well, that's just part of the job.
Well, maybe we can talk a bit about you teach economics, so I mean, there's obviously like supply and demand at work here. In this book, you talk a bit about the supply and demand for clickable content online, right? And so what's driving the proliferation of fake news and so forth is that people are much more likely to click on provocative pieces, right? No, you're not going to click on something which is banal, but we also demand things that are in conformity with our priors, right?
Yeah.
But at some level, if it's telling us what we already know, well, that's not quite great. If it's telling something that's completely contrary to what we know, that's also not so great. So the perfect clickbait is something that confirms our priors, but adds a little bit of spice to it, and I think that's exactly what's you see exactly the same kind of supply and demand dynamics in the academy, right? So, what makes for a good Science or Nature article is not something that is obvious, but it's also not something which is completely contrary to what we want to believe. It's kind of something that's once you hear it, you're like, oh. Yeah, that's kind of cool, right? I mean, and that guy, was it Diedrik Stapel?
Yeah, Diedrik Stapel. Yeah, yeah.
Yeah, he was a master at this. I mean, somebody, and I feel like I have like sneaking admiration for these people, and I think that we ought to have a Nobel Prize for literary science.
Fiction.
Yeah, I mean, some of these I remember there was this reporter for the New Republic back in the 80s who would write these fantastical stories that were completely fabricated, but they were so cool. And I remember reading them and they're like, oh, wow, how did he get that? That's like such an amazing illustration of this point. And even after I found out that it was all fraudulent, I thought, this guy's a great writer, like somebody should hire him. So what exactly is the like, how do the supply and demand dynamics fuel this kind of bad science?
Well, let me talk about Stapel a little bit. Stapel. And so some of the studies you mentioned, for example, were thinking about eating meat made you more aggressive, or children who drew pictures with tears in them were more empathetic, or he put a coffee mug on his desk with M&Ms inside. And if you wrote capitalism on the coffee mug, people took more M&Ms.
Right.
Things that remotely plausible, but they're provocative, right? And he said he started out and he'd do these studies and he wouldn't quite get the p-value below 0.05. And then he discovered in his Excel spreadsheet, you just change a number here, change a number there, and you get the thing below 0.05. And then he thought, well, why go to all that trouble of conducting the survey and tweaking the data? I'll just make up the data in the first place. And he said, I wanted too much too fast. And so he started just making up data. And of course, he was caught. And now, not everyone gets caught, but we know historically he was caught. And like 55 papers were retracted. And like any good capitalist, what he did was write a book about it.
Yeah.
Make some money off
read that yet.
off his. Yeah, I haven't either. But he's going to make some money off his sins. And
I've debated whether to have someone like that on the podcast. All my academic colleagues say that would be a terrible thing to do, but I'm super curious about people like this.
I think it's just this whole thing that people don't want to be ignored. They want to have jobs. They want to get promoted. They want to get funding. They want to get famous, and the way to do it is publish papers to get papers published. And what journals like are things that are statistically significant and interesting, things that get a lot of media coverage. And so there was an example just, I think it was now a year and a half ago, it was in the British Medical Journal, and there was an article that claimed that if you had your surgery done on the surgeon's birthday, you were more likely to die. That the surgeons were apparently distracted by birthday wishes or thinking about the parties or whatever. And that got picked up by like 250 media around the world, news media around the world. And because it sounded kind of plausible, and yet it's really it's really something newsworthy. Surgeons are not paying attention and they're killing people. And then I looked at that study, and what they had done is they looked at certain surgeries. And so they referenced four of the papers that had looked at surgeries and done something else, like the age of the surgeon and number of patients in the hospital and stuff like that. And these other studies had done four heart surgeries, four types of heart surgery, and four types of cancer, or four types of heart surgery and 16 other types of surgery. Now, this particular paper did four types of heart surgery plus 13 other types of surgery. Now, why did they do 13? Why not 10? Why not 15? Or why not 16 so it added up to 20? That's because the 13 had given the low p-value. It gave them the statistical significance. And even with that, their p-value was only 0.03. I mean, they were barely able to sneak under the line. And then they did a bunch of other stuff in there too. Like the other papers all counted somebody dying if they died within 30 days of the surgery or they died in the hospital, never left the hospital. This paper did 30 days of the surgery. They didn't do if you died in the hospital. For some reason they left that out. You probably think of why they did that. And they had the functional forms. Instead of a linear form, a couple of variables, they did cubic. Now, why did they choose to do that? Well, obviously they tortured the data until they got something to get their p-value below the magic 0.05. And that's what journals love. This is British Medical Journal, one of the great journals in the world. And it's a paper that gets a lot of publicity for the journal and for the authors. And so that's the kind of stuff that gets published, even though it's very damning for surgeons if it were actually true.
Now, in the world of hypothesis testing, right? I mean, there are some remedies for this, and you point out that if you register ahead of time and you pre-specify the approach that you're going to take, you say, okay, we're going to look at these 10 surgeries, and you provide some kind of plausible rationale prior to running the test and looking at the data, then that 5% cutoff is an action, is doing what Fisher wanted it to do, right? So the number of false positives will be close to 5% and not 20, 30, 40%, right? So we have remedies in place. Why? I mean, I guess what's taken so long to get these remedies in place? And is there a machinery in place that will allow us to kind of do this consistently?
Well, I think it started in 2011 when this whole replication crisis really hit the fan, and that was when Stapel got exposed, and there were several very famous studies that didn't replicate, and people started thinking about it. And the way science is supposed to be done is, like you say, you state ahead of time what your hypothesis is, you go collect the data, and then you test it. It's very clean. And so the idea with pre-registration is you set ahead of time, here's what I'm going to study, here's my variables, here I'm not going to divide it by sex or by age or any of that other stuff, and I'm going to report the results honestly. Now, there are a couple problems with that. One is you can game the system. Like you can do the study ahead of time and then file the pre-registration, pretending that's what you're looking for all along. Also, Gelman has said, a lot of times you really can't anticipate exactly what you're going to do as you go along. And so, for example, I looked at a study that was whether there are more fatal motorcycle accidents on nights with a full moon. And when is a full moon? What day is a full moon? And it turns out it's in different days in different parts of the world, which is kind of obvious. But the researchers hadn't realized that ahead of time. And they ended up using full moons in London to study motorcycle deaths in the United States. They kind of messed that up because they didn't realize that they didn't think about the fact there are time zones and full moons are on different days. So you don't anticipate everything like that. And
what if you peer reviewed your proposal before you did I've had a lot of I've heard graduate students come and do their job talks, and these are people that are about to go on the job market, and they'll do their paper, and I'll be like, but wait, did you think about this? And they're like, no, I didn't think about that. But now it's too late, right? So should we think about like publishing our proposals we should have a proposal journal and then a results journal, and then that way we can get because we want to know the flaws before we do all the work, right?
Yep. That's a great idea. And so there's the power posing study where if you do a couple power poses before you have to give a talk like this one, I didn't power pose, but it claimed that you would be more effective. And that study didn't replicate. And so a journal, prominent journal, commissioned, I think it was 11 studies, and each of them had to pre-register exactly what they were going to do. And the pre-registration proposals actually went to, just like you say, several other psychologists, and they came up with useful ideas. Maybe you ought to do this. Maybe you ought to change that. Did you think about this? And the editors of the journal said it was absolutely marvelous. And that these outside reviewers were not criticizing, they're not tearing down, they were not, they were trying to be helpful. And the papers were much the better for it. And that's a terrific idea.
Now,
Another one, go ahead.
Isn't this going to be more expensive, right? I mean,
yes, definitely, definitely.
Yeah.
But undermining the credibility of science is pretty expensive too. And so when scientists tell us to take our vaccines and we don't trust them, that's pretty expensive.
Now, look, I mean, it's kind of a stretch to think that the reason why people didn't trust the scientists involved in the vaccine development is because of, the replication crisis, right? I mean,
yeah.
that's a post hoc rationalization,
yeah.
isn't it? I mean, do you think there is a connection there? I mean,
yeah, that's not the replication crisis. It's some people don't trust governments, and they think of science as part of the ruling class, part of the elite that tells them what to do, what to eat, what not to eat, what to drink, when not to drink, which vaccines they should take. And it's part of a general distrust of government, which is fueled by these disinformation campaigns, especially out of Russia, what they call a fire hose of falsehoods, and just bombarding Americans and Germans and Brits with the idea that their governments are out to get them and they shouldn't be trusted, trying to undermine faith in democratically elected leaders and institutions like scientists. And so it wasn't the replication crisis that was a stretch. I want to say before, another idea I think is a good idea is people doing replications. That's not a rewarding thing. Mm-hmm. You do a replication and it replicates. Well, you just wasted 6 months or a year and you got nothing to show for it. And so it needs an incentive. And so I think one thing is, if you're a graduate student or even undergraduate in a field with empirical research, part of the requirements ought to be you try to replicate a famous study. And then there's an incentive to do it. And then the replication gets done. Or another one, which is even more extreme, is you put out replication bounties. And if you find a famous study that is flawed in some way, either the data are made up, falsified, or something like that, then you get a reward for it. You get some kind of reward for it, some kind of recognition, or even some kind of money, and give people incentive to do that. And it's not necessarily that the bad studies will be caught. It's the people doing the studies will think twice about doing them because they know there's a posse out there who will hunt them down. And especially in the case of fabricated studies, those are going to be out there forever. And eventually somebody's going to find them and you're going to be in trouble. And so it's a big incentive not to cheat in the first place. Like if Stapel had known that people were going to be checking his work very carefully, he might have not done the misdeeds that he did.
Well, you also talk about a lot of these kind of journals for hire, right? I mean, the number of articles that are published every year is just astronomical, but the bulk of them are pretty ignorable, right? I mean, it's astonishing. I couldn't believe Elsevier, which is every university pays them a massive subscription fee, except Berkeley. I think we cut them off.
Millions of dollars.
Yeah, and they publish all these fake journals. I mean, it's kind of astonishing that you can submit a bunch of nonsense and it will get accepted for a fee.
Well, the other part of that is it's not just the journals proliferating in order to collect money from desperate researchers, but desperate researchers paying for papers. And so there's an example of that SciGen computer program that was created by 3 MIT students that would generate random. It was so primitive compared to ChatGPT. It just took random scientific words and strung them together, and they submitted it to a conference and it got accepted. And that was the point, was to prove that conferences will publish anything. But since then, people started actually using SciGen to generate papers, submitted to journals, and getting them published. And there was a guy in France, I can't remember his name right now, but he found 250 papers in reputable journals, like Elsevier journals, who claimed they did peer review, and they published SciGen generated papers, which were utter nonsense. And then you have these paper mills, and what it is they provide editing services, and what that means is you pay them $750 to $5,000, and they'll give you a publishable paper, which has been fabricated or plagiarized, or they'll put your name on a publishable paper, which has been fabricated or plagiarized. And there are thousands of those things out there, and hundreds of them have been retracted, and thousands have not been caught yet. And now we got LLM, we got large language models, which are a lot more efficient than they're better, more coherent than SciGen, and they're a lot more efficient than individuals hand plagiarizing stuff. They can generate BS instantly, and the journals are just going to be flooded. I mean, it's already started. LLM generated papers are already being published, and some of them, you get the paper, and they get the conclusion, and the conclusion will say, everything up until now was generated by ChatGPT. The little gotcha there. Well, there are other papers which don't have that little conclusion. They're completely generated by ChatGPT, but they're not revealing it because they want to put that paper on their resume. And the journals are going to be absolutely swamped with junk papers, and other than pre-registration or bounties for people who catch this stuff, I don't know what the solution is.
Right, and one of the paradoxes I think that you're highlighting is that the quality of scientific research and discovery is not necessarily correlated with the advances in quantitative techniques and methods and the technologies for collecting data, right? So, I was been teaching data and decisions and kind of traditional inference and statistics for decades, and I guess it was about 10 years ago that I started teaching data science as well, right? And the promise of these large data sets and the kind of rapid computation that is enabled by these new technologies is incredible. It's powerful. It's amazing. But I think some people would argue that it's generating more chaff than wheat, right? So
Definitely.
If we have all the problems that you've articulated related to hypothesis testing, when we move into the world of data science, there's a world where we don't even bother with hypotheses, right?
Yep.
We just do data-driven discovery, right? We throw a whole bunch of data at the wall and kind of see what happens, and nobody even cares about p-values, right? In the world of data science. So I mean, is the proliferation of new technology and the massive expansion in the amount of data, leading to maybe worse science on average potentially?
I don't know how you measure the average science, but data mining is definitely a problem. And back when I was in graduate school, it was considered a sin, like plagiarizing. That you got a database, you went through it, you found some statistical relationship, and then you pretended that's what you're looking for in the first place. And of course, modern computers and modern data sets, it's data mining on steroids. And it goes by the name also HARKing that you alluded to before, which is hypothesizing after the results are known. And the problem is these computer algorithms, they're really, really good at finding patterns, statistical patterns, but they have no way of assessing whether it makes any sense or not. And so they can find correlations between Trump tweeting certain words and the price of tea in China. And that's a true example. But they have no way of assessing whether that is likely to be a meaningful or meaningless thing. And too many people think that data mining is a virtue, and I continue to consider it a vice. And an example recently, I think I mentioned this in the book, is the NBER paper, co-authored by a famous professor at Yale and one of his graduate students, who's now a professor, I think, at Carnegie Mellon. And they're trying to explain Bitcoin returns.
Right.
And there's no real explanation. I mean, stocks and bonds, you have a cash flow and you can discount it. You can talk about, future value and whatever you want. You got something to hold on to with. But Bitcoin as an investment, how do you explain why the price goes up or down $1,000? And there's no logical explanation. So what they did is they did 810 correlations with just data they found, like the U.S. Canadian exchange rate, stock returns in the beer industry, stock returns in the book industry, just all this data they had. And out of the 810 correlations they looked at, they found, I think it was 63 that were statistically significant at the 10% level. And if they just looked at random numbers, you would expect to find 81. They only found 63. And they found these preposterous things like Bitcoin returns are positively correlated with stock returns in the healthcare industry, negatively correlated with stock returns in the fabricated products industry. And they just shrugged their shoulders and said, we don't give explanations, we just document behavior. And these are surely just data mined coincidental correlations. And what's the point of documenting coincidences? But that's what they did. It was an NBR paper, and now it's published in one of the premier finance journals. It's just...
Yeah, but I mean, if we discover through that process some relationships that have some, plausible theory that we can construct around them, then, we should, I mean, for instance, suppose you were to discover that Bitcoin prices, correlated with, mentions in,
Google searches or something, yeah.
Google searches or something like that.
Yeah,
I mean,
yeah.
you could construct a plausible
Yeah.
theory around that, right? And
Yeah.
and if you could actually develop a trading model that exploited that forecasting capacity, then you could make some good money, right?
Well, the important part is there's got to be a human component to think about whether it's logical or not. And a lot of these trading algorithms are black box. And the people who run the company say, we frankly have no idea how they come up with their decisions, but it's a computer, so we're going to trust it. And the other thing, of course, is you need the replication. And so in finance, back-tested theories are a dime a dozen.
Right.
And factors, just in stock returns, there's literally hundreds of factors have been found that correlate with stock returns. Back-testing. But that's not useful. What's useful is forecasting. Can you actually make money on it, like you say? And so before you run out and bet the bank or bet the farm, you need to have you need to test it on fresh data, not on the data that was back-tested on. But again, it's got the human element. It's got to be in there. And does this thing actually make any sense? Like Trump's tweets of the word ever and the price of tea in China, you and I would laugh at it, but a computer program wouldn't laugh at it. They might think, oh, that's a good trading algorithm for buying stock in tea companies.
Right. And so, there's some easy ways to identify flaws in your methods, right? So there's, out of sample testing, right? There's, there's biased training data. I mean, there are these qualitative ways to think about whether you're doing good science. Since I teach in the business school, I'm usually emphasizing those things and not the nitty gritty of the techniques. And so I highlight the dangers. If you hand the keys of your company over to the data scientists, you might do more harm than good, right? Because oftentimes the people who have the most technical expertise are also the ones that kind of don't have this qualitative awareness of error. I mean, you have some great examples in there of how radiology gone wrong, right? Or diagnostics gone wrong simply because they were classifying based on irrelevant things like where the patient's lying down or sitting up, right? Or where what was the location of the
Right.
I mean, do you think that when we teach these topics, we tend to emphasize the kind of the techniques, the technologies too much, and not the kind of qualitative understanding of what's going on?
I do. And so when I read a prospectus for some fund and it says we use a blah, 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 computer algorithm, AI, blah, 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 we eliminate all subjectivity on the part of our managers. That's a big red flag for me. You're going to trust the computer to find a correlation, and you're going to make decisions based on that without humans stepping in and saying, wait, let's think about what it's doing. And so one of the lines from one of my other books, The AI Delusion, is the problem today is not that computers are smarter than us, but that we think they're smarter than us. And we trust them to make decisions they shouldn't be trusted to make. And so in finance, that's absolutely, I think, essential that you can't trust a black box algorithm. The other thing about, you mentioned out of sample forecasting. Well, the problem is you get enough things, like in that NBR study, they had 810 and they got down to 63. Now you do out of sample testing, and I actually did that with a student. We did out of sample testing for those 63, and some of them held up out of sample, about 10% of them. And so just if you're doing random numbers, 10% of 10% of 10%, how many times you test it, if you test enough theories, even if it's random numbers, some of them will pass one test, two tests, three tests. And so at some point you got to either keep testing or you got to step in and say, wait a minute, this doesn't make any sense. Why are we looking at this?
Well, right. I mean, you recount the story about how you were talking with a professor who said, that Warren Buffett probably doesn't have any skill because, right? I mean, if you flip enough coins, you're going to wind up with somebody who does really well. I mean, isn't that sort of if you go too far with your skepticism, then isn't that kind of where you wind up, right?
Yeah. And so this is actually a Stanford professor, John Chauvin, who's a good friend of mine. I don't know if you know him or not. He's a prominent Stanford professor. And he bought into this thing that efficient markets, nobody can beat the market. And so if anybody does, it must be luck. And so I was talking to somebody about Warren Buffett was a counterexample. And he said, enough monkeys hitting enough keys on a typewriter. And the idea is that of all the people who've invested in history, somebody's got to be lucky. And I actually disagree with him. I'm on the Buffett side in that Buffett actually makes sense. What he says is supremely intelligent. And it's not just he's not just throwing darts at a dartboard. And I mean, the other thing Buffett has written a paper about.
But couldn't you just say, all right, the top 5% of the people, right, are in that 5%, and then each one of them, I'm sure, has some kind of plausible story as to how and why they make money, right?
Yeah, and my criticism of Buffett is actually somewhat different. It's that he's got a couple things that you and I don't have. And one is he's got a reputation. And so he can go to a company like Goldman Sachs or somewhere else and say, I will boost the credibility of your company if you give me the sweetheart deal and I'll invest in you. And you and I can't do that. We can't go to a company and say, I'll invest $1 million in you at a sweetheart deal because your company's going to think better. And then the other thing is he's got those insurance companies and the float that he gets on those insurance companies. And so insurance policies are priced to give extremely conservative rates of return on the float, like T-bill rates. And so for most insurance companies, they say we want to be very safe and conservative, make sure we can make our claims. And so we'll invest in very conservative things. And Buffett, Berkshire Hathaway, he's got so much money, he doesn't have to worry if stock prices temporarily go down. He can still cover the claims. And so he can take money essentially borrowed at T-bill rates and invest in the stock market and get great leverage and great returns. And I made a calculation the other day with it was recently like 30 to 50% of his profits you would explain by the leverage float he's getting, the rate of return on the float, borrowing at 2% to invest at 10%. And again, that's something you and I can't do. We're not going to start an insurance company and have billions and billions of dollars to back up our claims. And so I think that's part of the secret success. But I think he's a smart guy. And stuff he says makes sense. I'm a complete value. I don't know about you, but I'm a complete value investor. And
well, I mean, I remember I went to visit a hedge fund, one of the largest hedge funds in the world, and they had just hired some of the world's best, machine learning engineers, and they were looking for patterns, and they were perplexed because as soon as they identified a pattern, it disappeared. Right? And they couldn't figure out why this was the case because that's not what you see typically when you're doing pattern recognition in other domains, and when you're kind of studying strategic actors, right? They're kind of a moving target.
Yeah,
and so
I had a friend who worked at JPL, and his background was like rockets. And you see a rocket, and you see the trajectory, and you write down the equations, and you fire another rocket, and it pretty much it follows what you had predicted. And so he said to me, Gary, I know you're in the stocks. I want you to give me all the data you have on the stock market. I'm going to run it through the big computers and figure out the patterns that beat the market. And just like you said, he was really great at finding patterns that predicted the past, but really bad at predicting the future. And there's a Danish proverb that said it's very hard to make predictions, especially about the future. And the stock market is fundamentally different than, following the trajectory of a rocket or some other mechanical physical thing, which is governed by physical laws. The stock market is just such a jumble of stuff. It's really hard to find patterns that are useful. And that goes back to how I started this whole thing. 50 years ago, I started teaching finance, and I became acquainted with all these people trying to find patterns in the stock market, and they had this nasty habit of appearing and then disappearing, and that's just the nature of the beast.
Now, do you think at the professional and personal level, there's an optimal amount of skepticism, right? I mean, because if you're overly skeptical, right, then you wind up. I mean, some of the people who are conspiracy theorists, in a way, they're I don't know. I don't want to say they're too gullible, because in many ways they're too skeptical, right? They say, oh yeah, this science stuff, it's all conspiracy, it's fake, right? And so, I always find myself trying to figure out how to strike the right balance. You recounted Gottman, and I love this story because I've been going to workshops and seminars for decades, and everybody loves Gottman. They think this is great work, and I'm thinking, has anyone ever done any kind of out of sample testing of his model? And no one seems to be able to respond to that question, but everybody loves it because it seems like such a powerful result. And I don't really know if anybody has, but it seems like an important question. But if I'm going through as the naysayer at every workshop and every seminar, then at some point people will just kind of dismiss you. So what's the proper ratio of false positives to false negatives in your kind of skeptical worldview?
I'm skeptical on magic ratio, but let me talk about Gottman for a minute. So he has these things that you can predict whether couples could get divorced, and he's been doing this for decades. And what he does is he interviews these people, and then he looks for little things in their faces, little commonalities, little correlations between the way they express themselves, whether they look up, look down, whether their lips go up or down, and then whether they have gotten divorced or not. And he's been doing this for so long, and he has never, ever, as far as I know, done an out-of-sample test. It's all in-sample. These are the correlations. And there was a group, I don't remember the name right now, but there was a group of skeptical psychologists, and they tried to replicate Gottman's procedure with some data, and they got the in-sample stuff, and they got results like Gottman, and they'd set aside half the data for out-of-sample testing, and it totally flopped out of sample, of course, because you're just finding these coincidental correlations. On the bigger question about skepticism, I think I'm hardly alone, but like me and Andrew Gelman and all the other people out there who are pushing back on p-hacking and HARKing and stuff like that, it's meant to be constructive. It's meant to improve the credibility or even save the credibility of science. And so it's not like we're trying to tear down science. We're trying to rebuild it, doing proper statistical procedures. And part of it's, like we alluded to, it's education. Like a lot of people, Stapel knew he was lying, but a lot of the p-hacking and HARKing, people don't know their bad statistical procedures. They don't know what the pitfalls are. And so that's something that should be taught in every graduate program that does empirical research. They should talk about the pitfalls of bad statistical analysis. And it's not just jaywalking, it's bank robbing.
Yeah, but I mean, look, if you lay out the laws and the rules and you say, here's the procedures, here's how you do it, then you kind of have to accept the results if it passes that test, right? That's sort of the whole idea of this procedure, is to overcome any kind of priors and pre-existing biases. But if you do this, then you wind up with like Daryl Bem, right? And I mean, you could say, oh, maybe he didn't, but I mean, it looks like everything was done by the book. But if you do 20 studies by the book, one of them is going to be nonsense, right? Yeah. And so do you then say, well, because we think ESP is nonsense, you get, you have to have a p-value of 0.005, not 0.05. Like, I mean, do you, but if you do that, then you're, and some people would call this like, Bayesian, but I mean, if you do that, then you're essentially admitting your priors, right? And you're imposing a differential burden of proof on folks that are doing something that you don't believe in.
Yeah, that is true. So Bemsey, of course, was ESP. And one of his most famous studies was he had these students, I think, at Cornell, and they studied for a test after taking the test. And he claimed that people who studied for the test after they took it did better on the test when they took it. It's just absolutely unbelievable stuff. But then he wrote things. I can't remember exactly. I'll paraphrase here. But he was giving advice to young researchers in the field, and he says something to the effect of, the conventional way of doing this, you set out a hypothesis, you collect data, and you test it. Boring. Psychology is much more interesting than that. What you need to do is go on a fishing expedition. Look at the data this way, tweak it, throw out outliers, divide it in different ways, look for anything interesting. And, that's p-hacking, data mining, and HARKing. It's bad statistical procedure. And he was a prominent person in the field. And no doubt that's how he came to these ridiculous conclusions. And it is true. I agree, however, that strong claims require strong evidence. And so in the thing we did before, if you're going to claim surgeons are killing people on their birthday, you better get a p-value that's way below 0.05. And no funny business here with, well, I'm gonna cherry pick 13 types of surgeries, and the other thing they did, they left out cancer surgeries. I forgot to mention that. They did 4 heart surgeries plus 13 others and no cancer surgeries. And all the other studies they referenced included cancer surgeries. And so we got to be thinking, why in the heck did they leave those out? Except they want to get the p-value below 0.05. And so strong claims, you got to be scrutinized. It's got to have a low p-value, and it's got to replicate. And I can't argue with that.
Right. No, I understand. We want to scrutinize these studies, but if we differentially scrutinize them, right? If we scrutinize the unorthodox stuff more carefully than we scrutinize the orthodox stuff, then aren't we sort of reinforcing the orthodoxy, right? And isn't,
we are.
Isn't that sort of a danger that we make life difficult for the folks who are discovering new things?
Yeah, it is. And so we'll put it in a somewhat non-political view, like you alluded to before, Bayesian. And so I start off with the prior that there's no ESP. And so I'm going to require a lot of evidence to convince me otherwise. And it is true it's become politicized, but a way you can handle it without just saying, I'm going to dismiss it out of hand, is to say, I have some prior on this, and to nudge me, to move me away from my prior, you're going to need more than 5 observations. You're going to need a big study with a lot of people. And it's going to have to be a study that is done perhaps with a pre-registration, say in advance exactly what you're going to do, and then do it.
Yeah, now this is where you have a lot of policy proposals at the end of the book, Distrust. And some of them have to do with the general public, right, and social media, and how research and ideas and stuff get diffused. And some of those are very controversial, right? Because in the book you talk about surveillance capitalism, and you talk about privacy and so forth. But it seems like a lot of the proposals that you're recommending would require some kind of infringement there, right? So getting rid of anonymity and having sort of KYC, and then having the social media platforms adjudicate, right, the veracity of the content. And that I think that's sort of, some people would argue that sounds like China, right? That's kind of what China does.
Yeah, it's a tough nut. And so freedom of speech is I highly value it in our country. Most people in our country highly value it, and that's a tough thing. I think one thing can be done that doesn't abridge freedom of speech is to cut down on the bots. And so I saw an estimate just yesterday that 44% of all the things on the internet are posted by bots right now. And if we could somehow get a way to get rid of all the bots, I think that would go a long way, because the disinformation is fueled by these bots. And somebody, a bad actor, say it could be Russian, could be Iranian, could be American, could be German, could be Israeli, could be British. They put something up there to try to undermine belief in something. Like the Russians might post something about, oh no, these Ukrainians have gone into Germany for refuge. They're raping German girls. And then the bots start liking it and reposting it and resending it, retweeting it, whatever platform they're on. And pretty soon it's high trending, and pretty soon people are seeing this. And if you got rid of the bots doing all the liking and the retweeting and so on, those things would have a much tougher road to get to the top of the trending list. And I don't think that abridges freedom of speech to say bots, no bots allowed.
Mm-hmm. Well, I mean, humans can do that stuff pretty quickly too, right? I mean, people
Not
retweet
as
a bunch
fast
of
as us.
nonsense. Yeah. But look, this book came out, I mean, I guess it was just recently. I mean, I have the preprint,
Yep.
but
March. Yeah.
yeah, and you cite some GPT-3 examples in the book, and
Yep.
they're laughable. And I post a lot of examples of GPT-4 doing a crappy job. But even since the publication of this book, there's been enormous progress in this
Yeah,
area,
it's
and
it's undoubtedly getting better.
the quality of the bullshit is much better than the quality of the bullshit that you reference in the book.
Definitely.
And so
I
a lot of people have used that term bullshit. Why is that the best descriptor of what GPT is doing?
I'm not sure if it is, but I actually got an example I did this morning. Okay, I asked ChatGPT, please write a biography of Gregory P. LeBlanc, Haas School of Business. Gregory P. LeBlanc is currently the faculty director of the Professional Development Programs and executive director of the Berkeley Center for Law and Business Economics.
That's wrong.
He holds a Juris Doctorate degree from the University of Chicago Law School,
That's wrong.
a Master of Economics from the University of Chicago,
That's wrong.
a Bachelor of Arts in Political Science and English Literature from Louisiana State University.
That's wrong.
He served as a professor at various leading universities, including the University of Chicago, UCLA, and the Hong Kong University of Science and Technology.
Wrong.
He's also worked as an attorney for several prestigious law firms, including Morrison and Forster.
Nope.
Now this stuff it's generating, it's stochastic. It's got some random stuff in there.
Sounds
so I
good.
asked to do it again. Regenerate. Immediately afterwards, the very next thing, regenerate. Gregory P. LeBlanc was born and raised in New Orleans, Louisiana,
Nope.
where he attended high school at the Isidore Newman School. He went on to study at Tulane University, where he earned a Bachelor of Arts degree in Philosophy and Political Science. Went on to earn a law degree from Tulane University Law School. It goes on and on and on. And so these large language models, it's absolutely astonishing. It's like, I believe they were set up originally for make autocomplete work really, really well. Mm-hmm. And then they discovered that you can generate whole sentences, whole paragraphs, whole papers in convincing, coherent prose. But a lot of it is just stochastic. The algorithm is apparently extremely simple. The hard part is training it on these big, large databases. But the algorithm itself is pretty simple. And so finding words that fit together, are likely to fit together stochastically based on all the patterns, all the data we've analyzed. And so it finds these things, has no idea what the words mean. It just knows that this word often goes after that word. And after those two words, this word often comes. And so it puts together these things, and sometimes it's really, really accurate. And sometimes it's just total BS. How would you describe this description of you other than BS?
Well, it's like what I tell some MBA students, right? Always certain, sometimes right.
Yeah, that's exactly right. And so the thing about large language models, and like ChatGPT or Bard, there's lots of them out there, is that they can generate this content which may or may not be accurate. And the problem is you've got to check. And if you know it, you knew already that all this was BS, right? Me, I might have thought some of it was true. And so I would have to go out and do some research, which makes the LLM kind of helpful. It gives me suggestions of things that I might look up, but it doesn't tell me things that are 100% accurate. And these models, like you say, they've gone through 1.0, 2.0, 3.0, 3.5, 4.0. They're getting more and more accurate, in part because they've got human trainers to go in and tweak it when they make mistakes. And you go to ChatGPT and it asks, do you like this answer? Or you not like this answer? And trainers are going in and trying to tweak the bad answers to get more accurate. But the fundamental problem remains that these algorithms don't know what words mean. They have no way of internally telling whether something is true or false, because they literally do not know what any words mean. Mm-hmm. And when you use them for something like I alluded to before, trust computers to make decisions for us. You trust a large language model to decide if you should be given a job, if you should be approved for a mortgage, how many years you should be sent to prison, those kinds of stuff. When it has no knowledge of what words mean, it's just looking for statistical patterns. It's treacherous. And I think the real danger of large language models is not that they're going to take over the world, but that we're going to trust them too much. They're going to make decisions that they shouldn't be making.
Well, certainly we could trust them too much. We could also trust them too little, right? So, I mean, it's finding that balance and figuring out, what they're good at and what they're not good at. And, I think we have now a hopefully new field of, literature. We'll call it behavioral algorithm. We in the world of behavioral economics, we love going around and pointing out all of the flaws and fallacies of human reasoning.
Yeah.
And so now, we can go around and point out all the flaws and fallacies of kind of machine reasoning. And at some point we can come up with some comparative advantage model of, how to divide the labor, right?
I actually speculated that for companies that are going to use large language models for things, it could be a law firm, it could be whatever firm it is, and they're worried about damages, being sued for saying bad things, or damages to their credibility. What they might do is hire fact checkers. And so you have the large language model do
what
something.
A concept!
A whole new occupation.
Yeah.
Fact checkers for the New Yorker, the New York Times. Mm-hmm. Now you got fact checkers for ChatGPT, and a whole new line of work.
Yeah, well, I mean, that's sort of how when you're generating images or ad campaigns, right? I mean, you use these tools to just kind of spin up some rough cuts, and then you can go in and sculpt them and craft them, right? And so that they do a lot of the heavy lifting, and then you can, so it's really about oversight. And so I like to say that just like you need to have grown-ups in the room who supervise the data scientists, you also have to have grown-ups in the room that supervise the large language models, right? And so I guess that's our job as educators, is to teach people how to be curators, interpreters, and managers of these tools, right? I was doing a workshop with a bunch of educators, and they were asking, like, how does education have to change when students can just have ChatGPT answer all the exams, right? And clearly it has to change, because if, and I guess this gets back to the bigger question, which you start the book out with, which is, are people really getting kind of stupider, do you think? I mean, this is a serious question. As a historian, I'm always I'm very skeptical of any of these trends, because people like to highlight certain stories. But just like we no longer can navigate our way to the bathroom without, Google Maps, we've kind of, outsourced that whole part of our skill set. Do you think that, I mean, when I hear about all these people believing in conspiracy theories, and I think, oh man, people are getting stupid. But then, look, I mean, they're burning witches a couple hundred years ago. So it's not like people were smart there's no point in human history where everybody was, walking around like a Bayesian, right?
Yeah. I was laughing because on some of these sites I'm on, these lists I'm on where they post things, people, every once in a while, someone will say, are machines getting smarter, or are we getting stupider? That's why I laugh. On the education thing, I think it could have a good effect on education. And, I'm a privileged guy. I teach at a small school with small classes, so I can do stuff like this, and it may not be scalable. But what are you trying to get out of education? And I think it's critical thinking skills and communication skills. And so critical thinking, the kinds of questions I ask my students they're not, who's the chairman of the Fed, or, what does FDIC stand for, stuff like that. They're questions that require critical thinking skills. And I've given those to ChatGPT, and they bomb. They can't do them. They can go back, if I have a question that they've got in their database, they can find it and give a plausible answer. But if it's something new that requires critical thinking skills, they do terribly at that. And then the other part is communication. And so we may be going to a world where my ChatGPT talks to your ChatGPT, but I hope not. And in most jobs, you've got to communicate. You've got to write reports that are persuasive and coherent and factually correct. And sometimes you've got to get up and speak and talk. And so in my classes, a lot of the things I do are group projects where they work on things outside of class, and then they come into class, they stand up and they present the results, kind of like a real world business situation. And the large language models are not going to take that over. And I think if education switches more to that model, teaching critical thinking, working on projects, communicating results, education is going to actually get better.
Yeah.
It's
But
not going to destroy education.
But is that going to make it more kind of labor intensive and less scalable?
Oh,
That's
for sure.
That's the kind of teaching that really requires much more kind of hands-on,
For sure.
direct kind of one-to-one interaction, right? You can't just stand up. I mean, there's kind of no point in standing up in front of a massive lecture room and talking to a couple thousand people. So when I think about accounting, right? In the old days, people would just learn how to add numbers. That was pretty much what they did. Now we have accountants that delegate that piece to Excel, and they have to think more creatively. So is that where we're headed? Where teaching people how to program and code, that can all be done with software, and then we can save the human teacher effort for the critical thinking skills.
It might be. I saw a thing the other day, it was a couple months ago, and it was a accounting firm, and they have a website where you can ask the experts tax questions. Mm-hmm. And they took the questions that were asked and they fed them into ChatGPT, and they got every single question wrong. And the questions were not trivial questions. These are people, they're asking professionals, so what do I do about this? Because I live in California and my wife lives in Florida, and if we sell the house, blah, 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 blah. It was kind of complicated stuff. But the ChatGPT was 100% inaccurate. Every single question it gave a wrong answer to, because it can add numbers. TurboTax can do great adding numbers, but you get some tough tax question, and you can't really trust the algorithm. Sometimes the experts have to step in and say, "Oh, you forgot this little thing here. Florida doesn't have a state income tax. Did you forget that?" And whatever the thing is. Mm-hmm. So I think AI is good as augmenting us. And so I use computers every day of my life. I'm sure you do too. And not just for writing, for statistical calculations, mathematical calculations. It would take me literally years to do if I had to do them by hand. And it's Monte Carlo simulations. I have stuff I run that would take several lifetimes if I had to do it by hand. And so that's great stuff. But in terms of what are the parameters of the simulation, I'm the only one to come up with that. I mean, or you're the only one to come up with the ones you want to do. The computer's not going to know what to do.
Well, Gary, thanks so much for joining me. I think we could probably talk all day. The latest book is called
definitely.
The latest book is called Distrust: Big Data, Data Torturing, and the Assault on Science. But don't forget Standard Deviations, right? Which I think is a classic. I think it's going to stay in print for a long time. Great stuff. Let's talk again soon.
Definitely. It was great fun.
This is Unsilo, brought to you by Alumni FM, connecting people through stories.